Hey guys, this was a question I got a lot of questions on from homework 5, number 2. And it's just, I think it's just determining the vectors associated with each one of these currents. So I thought that I would just walk us through it. I'm just going to start with I2 and its effect on position P. So that's basically what we're looking for, right? At this point, I have just like given the distances between each of these currents and their positions, and then R1 is the only one they don't give you. You just got to find that through PyTag. So let's just start with I2. You know, we put our thumb in the direction of the current. We curl our hands, our fingers, like doing that right hand rule, and we'll see at point P, that field right there, we call B2, is pointing straight down, right? And we know that it will be pointing straight down because it will be always perpendicular to this like distance between them. So it can only go like, point down or up, but since we know that our fingers are curling pointing downwards, we know that it's going to go downwards. Next, we can look at I1, same thing. Our thumb's coming out of the page, fingers are curling up, still perpendicular, so we know that we have a B1 pointing this way. And then lastly, with I3, again, thumb pointing out, fingers are curling westward or left. So it's going to be like this. Let's be 3. At this point, it's kind of like one of those force equations from last semester, or force problems, where we have a bunch of things in different directions, and we need to find that net force. So we can just break down this guy into its components, where this is theta, and also this is also theta. And I did a off-screen calculation, but you just use whatever trig function you want. But I just did a tan theta. I think it was like 26.6 degrees for that theta. So I already solved that. So now I know that B1 has both horizontal and vertical components. I'm going to draw my coordinate system. I'm going to be forcing the x leftward, and that's just because I want to work with positives. I can see everything in the x direction, that being B3, and the x component of B1 are both pointing leftward. So I just want to aim my coordinate system leftward so that I'm dealing with positives only. At this point, we know we're going to be using this equation. Solve for that B net. So let's just start with everything in the x direction. B net x, everything in the x direction, we have a B3. And then also we have a, I'm going to draw in our x and y components of B1. We also have a x component of B1 touching the angle, so plus B1 cos theta. All right, so at this point, we're just going to, so I just want to double check everyone can see. Yeah, we're just going to use our equation, mu naught, the current 2 pi divided by 2 pi, and then that r value, whatever it is. So like here, we would do mu naught I3 over 2 pi R3. We already determined what R3 is. And then plus mu naught I1 over 2 pi R1 cosine theta. All right. So I'm going to pause the recording, plug in all my values, and I'll tell you what I get for B net x. So just stand by. All right. So I just plugged in everything, and I just got this value, and that's 40651. All right. So next thing we can do is just look at the y component. So for that, we just got to break it down again. So I'm going to call this B net y. What does that equal? So we know we have a y component pointing straight up. Let's call that B1 sine, not touching the angle, theta. And then we also have B2 pointing straight down against our defined positive direction with our coordinate system. So that's going to be a minus B2. All right. So again, same setup, mu naught I1 over 2 pi R1 sine theta minus mu naught I2 over 2 pi R2. And then again, I'm going to pause and solve. But something I like to do here is, factor out the mu naught 2 pi over 2 pi because they both have those. So that saves time if you already weren't doing that. So let me just pause again and plug in my calculator. Pause. All right, solve that out. That's a negative 0.40499. And at this point, we're really close to being done. All we need to do is plug into our Pythag equation, at which point we'll get B net. And then we just need to, actually, I'll do that. And then I'll show you how we define our final angle. So let me just draw this out. All right, and we're back. So what I did was I just drew out my triangle according to my coordinate system, and I see that B net x is positive, but again, I define positive as westward or left. So let's go in that way. And then my y came out negative. Again, pointing straight up is positive. So here it's going to go straight down. So I know my B net is going to be on some angle downward. I just solve for B net using Pythag, plugging in B net y and B net x into our equation all the way at the top. And next I wanted to find my angle alpha, and I defined it relative to my coordinate system, 37.57 degrees below the plus x axis. So right here, this is our plus x axis going this way like that. Here we're below that slightly, so it's just 37 point, I think the answer key says 0.6, but 0.57 below the plus x axis. Okay, so that one should clear that up. Let me know if you have any questions.